Okay, guys, so we are, again, we know this unit goes fast, but it's because you're going to get better and better at learning how to name these things as we get through the chemical reaction part of this unit. So I know Ms. Merkus kind of talked about that a little bit. We purposely throw this at you very quickly. We don't have time to take a really, really long time in learning it. But as you practice more, you're going to get better and better and better at it. So just to reiterate, you are going to end up having a test. It's a mini test. It's only going to be worth half of the points of a normal test. That's going to be happening on Tuesday, October 6th. And the way that that test is set up is if you get at least 80% correct. So 80% or higher, you automatically get a 100 on this test. If you get less than an 80%, then that score goes in. But whenever we get to the end of the chemical reaction unit, you get another chance to redeem all of those points. And you will be surprised how much better you get at all of this naming. It's just all of a sudden going to click for you. And by the time we get to the chemical reaction test, it's going to feel easy. And I promise you, we've done this, we've taught this for 15 years. It's a foreign language at first for you. And then you're going to get better and better and better at it. We do not expect a lot of you to pass the first test. It doesn't happen. It's okay. Breathe. It doesn't mean that you are incompetent. It doesn't mean you shouldn't be in this class. You will be amazed by your growth by the time you take that initial test, and some of you will pass. This is just your thing. You're good at foreign language or something. So between the time you take that test and then the actual chemical reaction test, you will be surprised how much growth you've made in this, okay? So today we're going to learn how to name hydrates. We're going to learn how to name acids, and then we're going to learn how to name covalent compounds. So you want to be finding your note packet. That's what I have. So your guided notes. And in the guided notes, I want you to turn to page 4. So page 4 page 5 in your guided notes. We're going to start with the section that's titled Naming Hydrates. So hydrate, just like how we hear hydrate, get hydrated, have water, it's those compounds that have water attached to them. So when water is attached to the crystal lattice of an ionic compound, as it crystallizes. Hopefully you can hear me. So when water is attached to the crystal lattice of an ionic compound as it crystallizes. Sorry, I was wanting to find my crystal. So here is a model of a crystal, and it's this is an example of sodium chloride, but as the sodium chloride begins to crystallize, some crystals will actually pick up water with them. Okay, they'll pick up water molecules that become incorporated into this crystal lattice, okay, in set discrete organized amounts. Okay, so we name that, and we want to talk about that because it can impact how much of a certain compound we want. So you're going to need to memorize these prefixes. Some of them are going to feel pretty familiar to you. Others are going to be a little bit newer, but just realize a lot of this is taking time to memorize. Okay, this will be something that you'll have to memorize. So with this first one, I'm going to turn off one of my lights, see if you can see it a little bit better. All right, so with this very first one, whenever you are being asked to name compounds, you need to get good at recognizing where's the metal, where's the nonmetal. So the lithium right here, that's our cation. And because I've got more than one capital letter, more than two capital letters, I know there's a poly somewhere. Eventually, it's just going to stand out for you. But this right here is nitrate. Okay, so NO3, we see it as nitrate. Lithium, that's a type 1, so we don't have to write Roman numerals. Okay, we're just going to write the cation, then we're going to write the polyatomic. So this part is stuff that you've practiced, was introduced to. Lithium nitrate, now we need to say how many waters we have. This should be the very new part for us. So 5 is penta, like the pentagon has 5 sides. So then this would be pentahydrate. So the full name for this, lithium nitrate pentahydrate. Okay, lithium nitrate pentahydrate. Okay, so let's go to this one. We got a binary. That's a type 1 metal, so I need no Roman numerals. I would just write it as I see it. So sodium bromide. And now we have 4 waters. And you're going to see on your sheet there that 4 is tetra. So we would say sodium bromide tetrahydrate. Sodium bromide tetrahydrate. Now we get to this last one, and it's a ringer because we've got a type 2. So type 2 metal, plus I've got a poly in here. I see a bunch of capital letters. That's my clue to know that there's a poly. As you work through this, okay, and I tried to do this where I could write it on the board too, but I can't because I'm getting this really weird reflection. But as we work through this, we see that sulfate is a -2. So if it's a 1-to-1 ratio, this is what Ms. Merkus went through with you yesterday. So 1-to-1 ratio, and this is -2, this must be +2. So lead 2 sulfate, the new part, heptahydrate. Lead 2 sulfate, heptahydrate. Okay, lead 2 sulfate, heptahydrate. So you get some more review practice. I know it doesn't feel like review because it feels so new to you, but you do get some new practice of things you've already been introduced to. This is the new part. Okay, so that's hydrates. Acids are a whole nother beast. So whenever we think about acids and we're actually trying to name them, first of all, remember that an acid is going to be any compound that has hydrogen in it. So when I write H, starting with H, you're going to look and you're going to see like H2S, HCl, H2SO4. If it starts with H, unless it's water, H2O, then it's going to be an acid. And that's going to have a different set of rules for naming. Binary, just like how you've learned with the ionic compounds, just 2. So just 2 atoms, just 2 ions for binaries. So binary acids means that hydrogen bonded with the monoatomic ion. I should say anion, monoatomic anion. An oxyacid is whenever we have a hydrogen that bonds with a polyatomic. Okay, and in particular, there's a lot of oxygen that tends to be oxygen in it. There's one acid you'll name that doesn't have oxygen in it. That's not an oxyacid. It can't be because it doesn't have oxygen in it, but all the rest do. Okay, so there's just there are definitely quite a bit of rules with naming acids as well. Okay, here's the basics. And oops, that should say root, but it was way over here. But all of them should have root in there. So all the blanks are roots. You are going to have to, you can't just watch this video and go, oh, now I know how to do it. You are going to be forced to go back to this page in your notes again and again and again and process what you're being asked to do. Okay, so we first have to decide, is it a binary or is it an oxyacid? If it's binary, then we are going to write it a certain way. So we'll always use the root hydro if it's binary. If it's not binary, we don't use that root. If it's an oxyacid, so in other words, if it has a polyatomic, we have to look at the ending of that polyatomic, and we're going to change some endings. So if the ending starts with 8, we switch it to ic. If the ending has, down here now, if the ending has us in it, we switch it. I'm sorry, if the ending has ite in it, we switch it to us. Okay. And a little mnemonic to help you is we think like this. So going back up here, I ate something icky. So if the ending of the poly is 8, like sulfate, it would become sulfuric. You'll eventually learn how to make that switch too. If it was phosphate, it becomes phosphuric. If it was chlorate, it becomes chloric. So I ate something icky. Down here, if it ended with ite, so if it was like chlorite as our ion, as our anion, then it would become chlorus. If it was nitrite, it would become nitrous. So ite goes to us. And your little mnemonic to help you is invite us over for a party. So invite us, we spell us wrong, over for a party. You will have to come back to this. Like, again, you are being asked to learn a new language pretty quick. You're feeling overwhelmed right now, all right? Breathe. We'll see how you do on Tuesday, but this is the one time where a retake, you get to retest, you will do amazing on that second test. I promise you. Some of you are going to do amazing the first time. It just is, it's your talent, okay? Okay, so if here's some examples of some acids we can name. So this is just binary. It's not telling you hi, although I wish it was. Hydrogen and iodine, right? So hydrogen and iodide, if we think of the ion. So if it's just binary, remember, flipping back to your rules, that's whenever we have to have the hydro in front of it. So binary is the only time we write hydro, and we're going to always change that ending to ic in this case. So this becomes hydroiodic acid, hydroiodic acid. Now, I purposely picked other iodine-like acids so that you can see the different ways that we would name it, and they're very different chemicals. So now with this one, we have a poly involved. So I'll never use hydro again. If poly is involved, I drop the hydro. If you look on your reference sheet, your periodic table, where you see the polyatomic ions Ms. Merkus talked to you about, on that reference sheet, we would see that this is iodate. So I ate something icky, change ate to ick. So iodate becomes iodic. Okay, so then we basically just drop the hydro. So iodic acid, I ate something icky. All right, so here, another poly. I will not use hydro. We never use hydro if polys are involved. We look on our reference sheet, our polyatomic reference sheet, and we would see that this is iodite. Okay, so it's not iodate as an ion, it's iodite, I-T-E. So ite and us go together. Invite us to a party. So this becomes, we don't say hydro, this becomes iodous, I-O-U, iodous acid. So we have hydroiodic acid, we have iodic acid, and iodous acid. Okay, and these are all iodine-like acids. They all have iodine in them. So that's naming acids. Does not mean we think that you know how to do this 100% at all. Okay, some of you, again, it's going to come quicker than others. It's not easy for anyone. This is never a unit where somebody goes, oh my gosh, that was the easiest unit. But in January, you're going to look back at this and be amazed how much you remember. Okay, it's learning a new language right now. You are going to be able to pick it up. We use it all year long. Once you know it, you're going to see us practicing it all year long. Okay, covalents. We love to save the easiest one for the end. Many students feel like covalent naming is the easiest because you don't have to think about charges. You don't have to think about type 1s, type 2s. You simply have to follow this set of rules. And again, you're going to have to refer back to this quite often as you're going through the practice packet to know what I mean by follow this set of rules. Okay. So what do we do? Well, we're going to write the name of the first element with the correct prefix to indicate how many atoms of that element there are. There's one exception. If that first element only has one atom, we don't use the prefix mono. Just writing out the name lets us know, okay, there's at least one atom of that. All right. We're going to write the second element with the correct prefix to indicate how many atoms of that element there are. So we'll always use mono. So even if, like, think about carbon monoxide, CO. So carbon monoxide's formula is CO. It might be one of the ones we practice here in a second. We don't write monocarbon monoxide, but we always give the prefix for the second element, even if there is just one. So carbon monoxide. All right. Oh, yeah, there it was. Okay, so with this one, you have two nitrogens. So dinitrogen, and then you have 4 hydrogens. Dinitrogen, tetra, and we always put the ending as IDE. So dinitrogen tetrahydride. Okay, with this next one. Here, if anybody makes them, well, this one you wouldn't see it as much. I should do one more so you can see what people do sometimes. So oxygen, we only have one of those, so we'll just write oxygen. How many fluorines? 2. So oxygen difluoride. Oxygen difluoride. And then this last one, or not the last one, but you already know this name. We have 1 sulfur. So sulfur, how many bromines? 2. And we don't say sulfur dibromine. Change the ending to IDE, sulfur dibromide. And then, like I said, we're never going to write mono for the first, but we will write mono always for the second. So, and you know this compound that's familiar to you, carbon monoxide. We hear about that type of poisoning sometimes. Let me show you the one common mistake that I'll see students doing sometimes. And I do apologize for, or maybe once I hit blank, it's not going to, there you go. It's not quite as reflective. Okay, so add this as an example. Think of one that's really real. Hold on. We'll do this. Oh, good job, Zelensky. We'll do SF. No, let's do S2F. That'll show you what we're really doing. Okay, so S2F, what students will try to do sometimes is they read left to right. So they'll say sulfur difluoride. You're just reading like we would in English, left to right. But that's very inaccurate, right? It's not sulfur difluoride because it's really two sulfurs and really one fluorine if we were to write that in here. So this would technically be disulfur monofluoride. Okay, so just if I see a mistake, that's one mistake that I see repetitively. They'll try to read left to right, but always think that this number is indicating you got to put it in front. You got to write how many there are. Okay, disulfur, two sulfurs, one fluorine. So that gets us through the packet of notes that we wanted you to do. I'm going to do another quick video because there's so many practice problems. So I'll do another quick video showing you what practice problems we want you to do with your homework. But get your notes in. Be ready to ask questions. If you don't keep up with trying to do those practices, whenever it's question time, you're going to probably struggle a little bit. So get those in. Okay? All right. We'll see you guys later.